Hey guys, it's Mr. Post, and on today's video we'll be checking out a percent yield problem. Percent yield comes from this formula. The formula is experimental yield times 100 divided by the theoretical yield. And really it's a fancy way of saying, how much did you make in your experiment divided by what you thought you would make. Okay, so in your experiment you make something. Okay, so this is chemistry, and in a chemistry experiment we're going to have some reactions. And right down here is my experimental yield. That tells me what did I make in my experiment. Over here is a word, theoretical yield. Theoretical yield is a fancy way of saying what should you have made. Okay, it's kind of like the recipe called for making 24 cookies, and all you made was 20 cookies. Okay, so your experimental yield would be 20. That's what you made in your experiment. The recipe box tells me that I should have made 24 cookies. So really, what this ends up being is nothing more than a math problem. Is I made 20 cookies, I should have made 24, and what percent is that? And I'm going to multiply that by 100. That is what percent yield is, okay? So as we look at this in a chemistry sense, we're going to be keying in on what did my experiment say I made, compared to what did stoichiometry said I made. Okay, so when we do a theoretical yield in chemistry, the theoretical yield always comes from stoichiometry. Okay, the experimental yield is always going to be expressed in the problem. Okay, so that's not something you're going to have to deal with and work with. That'll be given for you. Check out the next slide here. Okay, 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of H2O. Okay, and one of the things we're going to key in on here is what is the percent yield in the experiment. Okay, how much did I make compared to what I should have made? As we discussed in the previous slide, my theoretical value is going to come from a stoichiometry problem. The experimental value will be expressed in the problem. Let's check it out here. I have 33 grams of hydrogen. It is going to react with 300 grams of oxygen. What is the percent yield if the experiment is going to produce 250 grams of water? So right off the bat, let me just pull this number out. The experiment is going to produce. Produce is another way of saying yield. So my experiment yielded, my experiment produced. Right here, the top value is going to be 250 grams of H2O. All right, that is my experimental yield. Experiment produced, experiment yielded 250 grams. What we're going to have to find out now is what is a theoretical yield? What in theory should I have produced? Okay, this comes from a limiting reactant standpoint. Okay, I've given you 33 grams of H2, and I've also given you 300 grams of oxygen. And the question is, which one of these is the limiting reactant? Because the limiting reactant is going to tell me how much of water I theoretically should have produced. So we're going to have a stoichiometry problem just like a limiting reactant problem, where my given is 300 grams of oxygen and my given is also 33 grams of hydrogen. Both problems are going to have an ending, and that ending is going to be over here at H2O. I want to find out using stoichiometry how many grams of water I theoretically should have made. The experiment only made 250 grams. So in the next slide, we're going to set this problem up. So let's write the givens down here, guys. I have 33 grams of H2, and I also have 301 grams of oxygen. And the problem is going to end over here in a theoretical yield. In theory, the question really is, how much water should I have made? Okay, that's the driving question here. How much water should you have made with these two ingredients? Now, as I set up every problem, I like to bookend the problem with this unit right here, grams. I want to be in grams of H2O. It's a good reminder for us to start the problem off with this. That way, we kind of don't lose sight of where we're going in the problem. On the periodic table, okay, if you look up periodic table, oxygen has a mass of 16, hydrogen has a mass of 1, and you have 2 of them. So really, you have 1 plus 16 to give me a mass of 18 grams in 1 mole of H2O. And we're going to write that down here as well. Alright guys, we're ready to rock and roll on the problem here. The ending set, I want to find out in theory. Alright, this is my theoretical amount of H2O that I'm going to produce given my two reactants. One of these is my limiting reactant. We're going to find out which one it is. Once you find out which limiting reactant I have, then I'll know what theoretical yield I will use. Alright dudes, so let's bust this out here. I have 33 grams of H2, and I know that in 1 mole of H2 there is going to be, from the periodic table, 2.0 grams of H2. I know now that I need a mole ratio. I need to convert from H2 into H2O. And I need a mole ratio here. And there are 2 moles of H per every 2 moles of H2O. Okay, we'll solve that problem at the end here. Let's deal with oxygen right now. Alright, the oxygen, I have 1 mole of oxygen is going to have the mass of 2 oxygens, and that's going to be 16 plus 16 from the periodic table to give me 32 grams of oxygen. And I'm going to need a mole ratio as well to convert from O2 to H2O. In the balanced equation, I have 1 mole of oxygen, and I also have how many grams of H2O? Moles of H2O, once again, 2 moles. Okay, dudes, last thing we need to do right now is bust out the calculator and solve this problem. Alright guys, after a little bit of calculation, I've solved the problem. It turns out that if I begin with 33 grams of hydrogen, at most I can produce is 297 grams of water. And likewise, if I begin with 301 grams of oxygen, at most I can produce is 338 grams of water. So theoretically, the most water that I can produce is going to be 297 grams. Alright, that tells me that hydrogen is the limiting reactant. Alright, that's good to know for us. But more importantly for this problem, at most I can produce is 297 grams of H2O. So when I try to find out what the percent yield of my reaction is, well, percent yield equals the experimental yield, which was 250 grams. So the experiment yielded 250 grams of H2O. In theory, I should have produced, let's go backtrack to the last slide, I should have produced 297 grams. That's what I should have produced. So the experiment did have some flaw. I did not produce as much as I really should have. So 297 is what I actually, should have produced. And this whole thing we multiplied by 100 to find out what my percent yield is. Let's calculate that. And what we end up with here is a percent yield of around 84%. Okay? So once again, guys, the problem is really to find out how much in theory I should have produced, and then divide my experimental product by really what I should have produced. And once again, what I should have produced is my theoretical yield. That comes from our stoichiometry problem. Alright guys, that wraps up percent yield. Thanks a lot for tuning in. Hope it was helpful. Have a good night.